All right, today is Tuesday, the 22nd of September. As I said, I asked everybody to go out to the in-class folder for this class, and there's a folder out there with today's date on it. We're going to go through some of those examples. We're going to finish the chapter. We're going to probably also do Chapter 7, possibly Chapter 8 too. We'll just see how the time goes. By no later than the end of this week, we're going to be through chapters 1 through 8 of the book, all right, by the end of this week. And you're going to get your next assignment. It'll be lab all next week, and that assignment's going to be due the 25th. I got asked this morning about grading. I'm in the middle of grading the Java stuff right now. I hope to have that done tomorrow, and then I'll start on whatever's next, all right? So let's bring the book up. We left off, I believe, last time on page 284, talking about arrays of pointers. All right. They do mention on page 284 there, it says array elements can be of any type. Should make sure I'm actually taping. I am. Good. All right. Including of type pointer. Arrays of pointers, as it says, have many uses. Quite often you'll end up using arrays of pointers if you have a if you write a program that's kind of menu driven. All right. Not always, but that's just one of the uses that you might have. All right, so it says to explain in this example here, you're going to write a program that uses an array of pointers to sort words in a file lexicographically. And if you don't know what lexicographically is, basically it's the way that words actually get sorted anyway. It's A through Z type of order. But when you work with numbers, typically, so if I have the number 11 followed by the number 2 in a regular type of sort, what's going to happen is the 11 will come before the 2 because 1 comes before 2. All right. So they go through an example in here, and I don't know if it's a great example or if it's a bad example. All right. But it says we need to imagine first how we're going to test it. Let's create a file, an input file with 2 lines in it. A is for apple or alphabet pie, which we all get a slice of. Come taste it and try. Wow. All right. It says to sort all the words in this file, you can give it this command. And I haven't even tried to do it like that because that's actually a Unix command, but I'm not sure if that would work on our system or not. All right. But what it says is the name of our file is input. All right. So that's the file that contains this. And what we want to do is we want to run that C file, and we want to use that basically as our input. All right? And when you're doing all this stuff, when you're inputting, you're going to use a less than sign. When you're outputting, you're going to use a greater than sign. Is that important for what we're doing in here? No, but I just thought you might want to hear it for whatever reason. All right? So notice what they have here. If you look over on page 285, it says char star WN, and as it says, that's an array of pointers. All right. One thing, just so you know when you understand this, one thing about C, there are a few things in the language that I wish they would have done that they didn't do, and since they didn't do them 50 or whatever odd years ago, they're not going to do them now. And some of the stuff that they haven't done sounds really simplistic. For example, if you've got an array, and that array has got X number of elements in it. You don't know how many elements are in it. There is no array length function in C. There isn't. You can write your own, but there isn't one. And what the people who created the language basically decided to do was, well, we're going to do certain things. And if you don't like it, then go ahead and create your own. All right. All right. The program shown right here, and let's look at the dissection for the program that's on pages 285, 286, 287, maybe even a little beyond. As it says there, you've got a couple pound defines at the top for your maximum word size and your array size. All right. It says we're assuming that no word in the input file has more than 50 characters in it, and that there are most 300 words in a file. Okay. They're going to use the array word to temporarily store each word that's read from the input, and they expect each word, again, as we said, to have less than that. So what they're doing with that char star n, as it says, this W is an array of pointers to characters. They will eventually store all the words that we read from the file. So what we want to be able to do is to read a series of words. Take each word, put it into its own array element, so to speak, so we're able to look at those, a maximum of 300, and be able to sort them, all right, and put them in some kind of a alphabetic type of order. And they mention, as long as scanf is able to read characters, and that's the for loop that you see here, right there, in the middle of page 285, as long as scanf is able to read characters from the standard input file and store them, the body of the loop will be executed. All right? Because an array name by itself is treated as an address, we don't need to write ampersand word right there. In fact, if you write ampersand word, anytime you're working with a string variable, if you put ampersand, it's not going to work. You may get something. If you're lucky, it'll be garbage. If you're not lucky, you'll be doing some damage or potential damage. Because strings, that variable out right there, basically, there's an implied asterisk. Sorry, an implied ampersand there already. All right. Now the function, as they mentioned right here, and this is, believe me, this is as hard as any class in this institution gets, is right here. All right, and in this program. Do I expect you to do this for your program? No. All right. We will look at this in a little bit more length and breadth of coverage in the next couple chapters after this next homework assignment, when we go through structures in chapters 9 and 10. All right. But what that catlock does is mentioned on the bottom of 286, it dynamically allocates space for an array of n elements. Because while it's going to keep reading. Oh, I got another word. Boom, I got to stick it. I've got to have basically another array location to hold that next word. Oh, there's another word. And it keeps doing that until it runs out of words. And the author mentions you could have also used malloc. That's no big thing one way or the other. All right. After the space has been allocated, the function string copy is used to copy word into memory starting at the address. So if you look pictorially here at what they show in the book, on page 287, this is what's happening. So there's certain things that are going to happen here. Every word that gets put in there is put in there as a string. And that's important because we want to be able to use string handling functions in here. So as it puts it in as a string, it has to also make sure that the \0 is on the end to make sure that it shows the end of the string. So as it turns out, if we account all the words that are in here, A is for apple, etc., there's 17 words. And that's the way that it ends up getting stuck into the array right there. All right. Then when you're done, you have to sort them and then write them out. And that's exactly what's happening here. All right. Now, this may or may not sound like an important thing to you, but really one of the most important things for you to hear, because again, this class is called Secure Coding, this is an example of an unbelievably terribly written function. All right. And it may not sound like it's that big a thing, but when you look in here, where am I? Not only is there a string copy, but see later on they came up with a function that's called strn copy. And the n that's in there stands for the number that you want to be copying. That's much more secure. Microsoft has actually banned this function from their code. So if you are working for Microsoft and you use strcpy and you go to a code review, they'll tell you you got to take that out. You've got to either change it to strn copy or to something else. All right? Because it allows for buffer overflows. And with a buffer overflow, what you're doing, it's the proverbial trying to stick 10 pounds worth into a 5-pound bag. All right? And it allows you to conceivably overwrite memory or something else. So as it says on the bottom of 287, the function sort words is used to sort the words lexicographically, and then write words is used to write those sorted words out when you get done. Now, I may have made that easier to understand. I may have made that harder to understand. If I made it harder, sorry, I wasn't trying to. All right. Wanted to show you this. That's how most C programs are written, just so you know. All right. What we've done pretty much in here for our main is we've either done this, void main, paren, or we've said something like maybe int main, okay, one of those. That's not how most C programs are written. In most C programs, they're written like this. All right. And we haven't talked about it till now because we haven't really gone over pointers until now. All right. So most C programs, their main is designed to return an integer. All right. And this stands for argument count, and that stands for argument vector. All right. Because especially if you run a program from a command line, there's at least a chance that when you run the program, let's suppose that we wrote a program and we just called it greeting. All right. So you already know this, but when we run our program, we say cl greeting.c. And if everything works, then we say greeting. And you might not think anything of it. Well, you've already been using this, just so you know. Your argument count, when you've been running this, has always been 1. And really it's argument 0, but the count has been 1. Because the name of the program is always going to be your first argument. It always is. But you can write things so that at the command line, what if we wanted to set it up so when you said greeting, you would ask the person for their name on the command line. So in other words, if I said greeting Micah, the program would come back up and it would say good morning Micah, type of an idea. All right. Then your argument count would be 2, and that would be arg0, and that would be arg1. All right. And the only reason I'm telling you that is more often than not when you see actual application code, that's the way you see it. All right. So what is this? Well, it's a character array, but more than that, it's a pointer to a character array. And it's arg count and it's arg vector. They explain it probably much better than I could, and they show an example of how you can actually use it here on page 291. So when you look right here, again, the name of the program is myEcho, and it says A is for Apple, as the example shows here on page 291. All right, so the argument count is 1, 2, 3, 4, 5. And arg0 is myEcho, arg1 is A, etc. All right. And again, you might say, is this really all that important? Depends on the type of application you're working in, because sometimes you do have to pass things in as the program begins running. If you need to do that, all right, not in main, but before the program even begins running, then you've got to set it up like this. I don't know of any other way to do it. All right. One of the things about C that made it a little bit different from other languages is you can create what are called ragged arrays in C. And what that means is that you can have a different number of elements, all right, as you're working your way down. So they show you an example of it right here. All right. And what does that mean? Well, if you notice, if P is our array of words, then P sub 0 has 1, 2, 3 elements in it. All right, it's a size 3, and P sub 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, and again, is that an important thing? It kind of is, because C was one of the first languages that I knew of that allowed you to do that and create ragged arrays. They're not that big a thing today because a lot of languages allow you to create ragged arrays. But those who do allow you to do that, they got their roots, for lack of better words, from doing it in C. Yes?
So they don't consider the semicolon a character then? I guess in a ragged array.
You mean the semicolon or the \0?
No, I'm looking at the int more over on. I think that's where they're taking the example, the ABC, and then.
Oh, over here you mean?
Yeah, up at the int main, up at the top there. I don't know. It just got the ABC and then A is for Apple, and then I see the ragged array example over here. How they're trying to explain it, but I don't see. I don't know.
And character A for the.
Well, when they're breaking it down right here, they are considering each element, okay, that's in here. All right, but it says here, array sub 0 would be initialized to this. I don't know why exactly they're showing it like this. All right.
So like right, where you just have your cursor.
Okay.
Where the colon is.
Yeah, right there.
Why doesn't it count the colon as a character?
What's the change between two strings?
But it's inside the quotation, so.
Because they have a typo. No, it's not. It's.
Yeah.
No, I think they do count it. And when you look right here, what we're saying is this is a two-dimensional array. It'll have 2 rows, and each row will have a maximum of 15 entries in it. So that's row 0, and that's row 1.
Right, and then I'm looking at the ragged array over here on 293.
Okay.
Where it's ABC \0.
Oh,
How come they're not throwing, is it considered a character or no?
No, it would be considered a character. I don't know why they're not showing it.
Yeah, that's all I was wondering if they
Yeah,
could
no, I have
consider
no idea.
Okay.
I guess the author just took poetic author prose and said if he doesn't want to put it in there, he doesn't have to. I don't know. But yeah, it would be considered.
Okay, thank you.
All right. In C, as mentioned on the bottom of page 293, pointers to functions can be passed as arguments to arrays, returned from functions, and so forth. Again, this is heavy stuff. This is also, I believe, when they set up the stuff for jQuery, they looked a lot at this. So did JavaScript, to allow you to have anonymous functions. I mean, in JavaScript, you can use a function as though it's a variable. You can assign a function to a variable. And that's kind of what they're getting to here. And since jQuery is basically just a JavaScript library, you can do the same kind of thing. So the author mentions here on page 294, in the middle of the page, all right, he shows this file sum square, okay, and he's got a double sum square. Now notice what it is. What does it take? Well, it takes it says in the header, the first parameter tells the compiler that f is a function that takes an argument of type double and it returns a double. All right. And when you do set that up, as it says, X is for the human reader, the compiler disregards it. That's why, I don't know about you, but whenever I write my prototypes up on top, I write them just like this. No, in fact, that's even a lie. Because the author shows it like this. Let's make that a little smaller. But when you're writing prototypes, you don't even have to go to, that's interesting, you don't even have to go to that much degree. So if this was your prototype, you can just say double sum square double. Don't know if it would need a name right there, but I don't think it would. I think it would be okay like this, int. That's what the compiler sees. It doesn't look at any names you put in, all right? Because all it does is when you set up those names, it's associating memory addresses with them, and it's working totally with the addresses. Yes?
So when you're prototyping it, like up there, does the double need to be in parentheses? There's no name associated with it?
I believe that this, are you talking about the one right here? I believe this would have to, because that's showing a return type.
Okay.
Because otherwise it would think it was a double followed by a double, and there's no comma in between.
All right.
All right. And they give just a really ugly example up here. It says, we could have written it like this. Boy, I don't know if you want to do that, but you could have. And they explain what each step in here is. And like I said, this is about as heavy as this language gets. So f, as it says, is a pointer to a function. So asterisk f would be the function itself, and asterisk f k would be the call to the function. And they show how that's done on the middle of the page here. All right. Sometimes the reason that this is done too, just so you know, sometimes the reason this is done is because if you're working on a project that's a complex enough project, someone else may have written this function for you. So what you have to know is how to call it. You don't have to know so much how it works. And there's some of the stuff. I guess it did need a name there. Okay, Zane, you'd asked about that, and this is on page 296 in the book. All right. So you need not only the parens, but it did need a name there. But you don't need this int m, int n. All right, you don't need that. You can just have int. Okay, and I know that works. All right, the next thing, boy, that's just into the world of mathematics. They use bisection to find the root of a function. I read through it a couple times, and every time I read it, I got more confused than I was the time before. So I'm just going to jump up to page 302 and talk about arrays of pointers to function. In C, a function name by itself is treated by the compiler as a pointer to the function. So listen to that again. The function name by itself, not a call, but just the function name by itself, all right, is treated by the compiler as a pointer to the function. This, again, is almost synonymous with the way that it's done in JavaScript, all right, and the way it's done in jQuery, and the way it's done in some other languages, too. Technically speaking, the author talks about there, it says, we pass Kepler as the argument to bisection. Again, just really very, like I said, I found this very confusing, the stuff that's in there. If you think it would help, I would suggest you go through the examples that they show right there. When I went through them, I got more confused every time I read it. And believe me, I've got quite a few colors in here. I've read it quite a few times. All right? That's why I said I'm not going to give you anything like that. I mean, it'd be real easy to give you an assignment that would just screw with you and have you say, I don't have any idea what you're asking for. I don't know exactly what that would accomplish. All right, so the last thing that's discussed in the chapter on pages 307 and 308, the type qualifiers const and volatile. As it says, const and volatile have been added by the C language to the C language by the ANSI committee. They're not available in traditional C. That's why you can use const just like you use const in other languages. And they show you an example of it right here. But most application programs you see will still use the pound define. The advantage of using const, all right, is, well, there's two. One is that that's the way it's used in many other languages. The other one is you do have to put the type in there. So you're letting the system know that you are setting up a type. So typically in a declaration, const comes after the storage class, if any, but before the type. So they show an example halfway down there on 307, static const int k equals 3. It says, we read this as k is a constant integer with static storage class. All right, we can initialize k, but thereafter k cannot be assigned, so it can't be changed in any other way. In C, even though a variable has been qualified with const, it cannot be used to specify an array size in another declaration. But you can do it in C++. All right. As opposed to this, if you look down toward the bottom of page 308, way down here, I'm highlighting it in blue. The author says, in contrast to const, the type qualifier volatile is seldom used. A volatile object is one that can be modified in some unspecified way by the hardware. And normally when you put volatile in there, that's what you're using it for. Is you're using it for system type of code. So if you were writing an operating system or something like that. All years ago when I went and got my master's degree, I signed up for a compiler class because we were going to have to write our own compiler. And I thought, well, that would be really cool to do. And I knew it was going to be a lot of work. Halfway into the class, everybody, there were a bunch of us who took it from AT&T. We all dropped because we were convinced the instructor didn't have a clue as to what he was talking about, because the class just got worse and worse. All right. Let's jump into the next chapter. I'm not going to cover all of Chapter 7. Chapter 7, again, which begins on page 320, no, make it 331, talks about, it says there, bitwise operators and enumeration types. And the first thing that's discussed there in some length and breadth of coverage are the bitwise operators. Okay? When you do a bitwise comparison, you're comparing bit by bit. So in other words, if I do a standard type of thing in C, so if I come in here and I say int x equals 7, int y equal 10, and then later on in the program, let's say we'll make int z equals 0. And then later on in the program, if I say if x equal 3 and y equal 10, then I want to do something. All right. When you put the double ampersand in there, that's a non-bitwise comparison. Okay, that's just comparing this as opposed to this. When you put just a single one in there, C, like a lot of other languages, does short circuiting. So if I let's put it back the way it was. If I put this in there, is x equal to 3? No. So it never does that compare because it doesn't have to. As soon as it finds that it's an and the first part's false, it says there's no use in going on. Sometimes, though, you want it to go on, and you want it to do both comparisons regardless. If you do that, then it does. Then that's what you put in there. That's the difference between them. All right? They go through some bitwise complement, and there's some math stuff that's in here. The reason that this stuff in here is at least somewhat important, all right, if you want to read it, feel free to, of course, but this is how the computer does math, okay? Everything's got to be broken down into zeros and ones, and they explain that in here. They explain how you can use masks and a few other things. But I'm just jumping up to page 345, and I want to talk a little bit about enumerations. All right. You've heard this term in Java before. We'll look at enums now, and you'll see enums later in chapters 9 and 10 in more breadth and depth of coverage than we're talking about right now. All right. So what we're doing in this line that you see right here on page 345, where it says enum day, and it's got sun, mon, etc., all that different stuff that's in there. Okay, you're creating a brand new data type. That brand new data type is called day, and the values that it can have are sun, mon, tu, etc. By default, just like you've seen in other languages, this is equal to 0. This is equal to 1, etc. If I wanted to change it, so normally I wouldn't want that because we don't really have a day 0. So normally I'd say something like this. All right. So then sun is equal to 1, mon is equal to 2, etc. We can set that up any way we want. So quite often when you use things like this, you'll use enumerations and you'll set them up if you've got days of the week or months in the year or something that pretty much is standard like that. I think they have there's an example later on that they use for cards. All right. And they set clubs equal to 1, diamonds equal to 2, hearts equal to 3, and spades equal to 4. And I think the reason that they do that, and many books do this when they start to explain this stuff, is they say, okay, you want to set up a deck of 52 cards. All right? And you want to make sure that you've got 13 of each suit. Well, that's what they're doing. So now they've got 4 different suits. So now they have to worry about the numbers 1 through 10, and then Jack, Queen, King, and Ace. or Jack, Queen, and King, I guess. But as you would guess, they set up this enumeration in here with different suits. You could also set up an enumeration with the different card values. So you could have ace equal 1, 2, 3, 4, 10, and then jack, which would automatically be 11, etc., depending on how you wanted to do that. All right. But the idea is an enumerated data type is a user-defined data type. So they create it right here. Then underneath it, they say enum day. All right, so you need the word enum, and then the type you've just created, and that's going to declare D1 and D2 to be two variables of type day. Now, the syntax that's in here is different than the way that it was in Java. All right. First of all, in Java, they typically always put those values that are in there in caps. And then in Java, it would have been like D1.sun or whatever. Here, you don't have to do any of that stuff. You can set up enumerations for just about anything. Where enumerations oft-time are used is for something like this that you see here on page 347, just to make your code a little bit more readable. All right. And you might not like the fact they use sun, mon, TUE, etc., but they could have used the entire, if they wanted to, they could have used the entire word. All right. But now they're all three digits long, or 3 characters long. And again, you oftentimes you see that same stuff with a month. Okay. So I'm not going to go through this, but if you take a look on the next page, oh, looky what they have. They've got a game of rock, paper, scissors. Originally, I was thinking of asking you
I
to.
still have one more question
Yes.
on there. If, let's say D1 is Wednesday,
Uh-huh.
we start with Wednesday, then D2 would be Thursday. So,
For what page are you on exactly?
page 345.
345. Okay.
If we start at Wednesday as a D1.
If you wanted, if you say this, or
Yeah.
like this equal Friday, this has no bearing on D2. This is just basically, this is just setting that variable.
Okay, but that variable start from, let's say, instead of Sunday, if we start on Wednesday.
If you started on Wednesday, so if you went WE, if you just imagine that you put the Sunday, the Monday, and the Tuesday after the Saturday, you can do that if you want to.
Okay.
Yeah. Yeah, you can set it up any way you want to. And that's really almost it for the chapter. It's a very short chapter. There's not much in it. Whoops. That's it. So I wanted to take a second and take a look at a couple of the preprocessor things that are in here. Then we'll take a break, and then we can come back and look a little bit. I think there's a little bit on files in this chapter also. This is also a quite short chapter, though, which is fine. All right. Am I right in assuming that by now that everybody understands what this means and the difference between using pound include with angle brackets and pound include with double quotes? That if you use the pound include with angle brackets, that means it's a system header file. So it's defined someplace in the system. If you use the double quotes like that, it's your header file. All right, you can define your own header file and you can have it put in anything you want it to put in. Pound defines, we've talked about those also. Okay. They mention on page 367, first full paragraph on the page that's in blue up on your screen, symbolic constants and documentations. Typically it says replace what might otherwise be a mysterious consonant with a mnemonic identifier. All right. So rather than you saying something like 2,147,483,647, when most people, when you see max int, it makes a little bit more sense. EOF is just kind of a standard way to say end of file. All right. All right. What you can do with this language is you can write macros. What a macro is you kind of embed code, for lack of better words, you embed code inside of variables to make them do what it is you want them to do. So notice here, they're pound defining a macro that's called square. All right, it's SQ. And you pass it X. Notice how they define it inside of here. You need to put each one of those in their own parentheses. It's explained in here much better than I could. All right, but if you wanted to set up correctly, you have to do it like that. So as it says, so if you did this, and the example they show here, I'm not sure why he shows that one, but if you were to pass, let's just say 7 in there. All right, that would say 7 times 7, exactly what you think it would be. All right. And I probably, I've told you this already, but I still remember that working with a guy who worked at AT&T and wrote all his code like that. Then quit the company, went to work for a competitor, and farmed himself out where he went back to work for AT&T. He was a contract employee because he was the only one who could understand his code. When you write macros, you can embed macros within macros within macros, and he did it about 7 or 8 levels deep. Yeah, you'd have to know this guy. He was, as they say, a different bird. Unbelievably intelligent. All right, and a real nice guy. But all right, turning up to page 371, the author says here at the top of the page, C provides the type def facility so that an identifier can be associated with a specific type. A simple example, type def char uppercase. It says this makes uppercase a type that's synonymous with char. What? That means that after you do this, anytime you use this, all right, it's now going to replace this. All right? So you can now use, say that again. Anytime you're going to use this, you're now using this. So what this means is, if you don't like to use char in there, you could say uppercase. What it can do is it's sending kind of a subliminal message to the person using this. Oh, it's going to be a bunch of characters and they should be uppercase. You don't ever have to use this, but it can make your code a little bit more readable. There are people who argue and say you should never use this, and the reason that you should never use it is because there is no type of variable that's called uppercase. And if other people see your code where you're replacing, tried and true variable names that have been used forever, bless you, with ones that you created, that's bad programming. All right. The only other thing I wanted to mention in here, if you look and turn up to page 377, please. Oops. They give you an example program. Macros with arguments. And I'll let you take a look at that one because it's pretty ugly. All right. It says we will again fill arrays and sort them using quicksort, but this time we will use macros as arguments. What you can end up doing with writing macros is your code will become much more compact. You'll have less code. That's the good news. The bad news is it might be a lot less understandable even though it's less code, because unless somebody actually understands the underwriting macro, they might have a problem understanding your code. All right, it's 8:48. Let's take a break. We'll come back and we'll pick it up on page 382, talking about macros and stdio and ctype.h.